All right, let's do it together. If you didn't finish, that's okay. I know it hasn't been 5 minutes. It's only been 4, but that's okay. Stuff I want to cover today. So let's go through this together. So for the first one, we have y equals x squared plus 8x plus 4. Okay, so we have here a is 1, b is 8, and we have c is 4. Okay, so what do we do next? Well, just like we've been doing, we have to get the vertex first. So we have negative b over 2 times a. And from there, we get negative 8 over 2 times 1, as you can see, which is negative 4. And so from here, right, we have the x coordinate now. Now we have to get the y coordinate. That's what the equation, we can use the equation for that. Y equals, so we have y equals minus 4 squared plus 8 times minus 4 plus 4. And you can see that turns out to be minus 12. So of course we have the vertex, right? We note we have the axis of symmetry. It's always x equals negative b over 2a. Since a is positive, we know what the graph has to look like somewhat, at least the general shape of it. Right? The graph is going to open upward. So upward like this. As you can see, almost like a, how do I say it? Almost like a U without the tail. And we have these two arrows here. The vertex is down here, as you can see. And since it's opening upward, it's going to have to go from minus 12, the y coordinate of the vertex, up to infinity, as you can see. And not only that, if we were to think about where the vertex is, right? So it's minus 4, minus 12. So we know that the vertex is somewhere down here. You know, negative x, negative, whoa, sorry, let me fix that. Oh boy. So it's somewhere down here, right? Okay, and since it opens upward, I mean, I don't know where exactly it's going to pass through the x-axis, but we know it has to pass through somehow. So it might pass through both times here, right? But we know it has to pass through the x-axis. So we know ahead of time, right, that is going to be x-intercepts. Kind of like planning ahead, so to say. Okay, well, let's find them. So we have the y-intercept, which turns out to be 4. Okay, that's cool. Right? That's hopefully that's easy to see. You just replace x by 0. Here, we can use the quadratic formula. I did email you guys the notes. I hope everyone saw that. We have this for the quadratic formula. We're replacing a, b, and c into the wonderful formula. Doing so, we get negative 8 plus or minus the square root of 8 of the square root of 8 squared minus 4 times 1 times 4 over 2 times 1, as you can see. And we get this. 48 is not a perfect square. But that's okay though. Remember, you can use your calculators. You know, that's what I did to get these. I did not calculate these by hand. So what we get is the x-intercepts. We have two solutions, right? We have negative 8 plus the square root of 48 over 2. We have negative 8 minus the square root of 48 over 2. And we get a solution from plus, a solution from minus. We have these two. I will tell you ahead of time how many, what do you call it, decimal places to round to. Let me just say this also. I've seen students in the past make this mistake. When they're using the quadratic formula, they would include x squared with their a and x with their b. So in other words, they would have negative 8 times x, 8x squared. Basically what I'm saying is don't do that. A, B, and C are only going to be numbers. You don't want to see variables in here. Okay. So we have these x-intercepts. So now we have an idea what the graph looks like. Yeah, I just graphed in GeoGebra. Again, I'm not going to ask you to graph it by hand. I mean, in class, in an in-class exam, I would. But here we have this, -4 minus 12. Right, that's our vertex, which is, let me circle that. That's down here. We have our x-intercepts, as you can see. Yes, we do have x-intercepts. Well, we saw that already. We have our y-intercept, and so on. I mean, from here, I hope you can see what the range is anyway. You know, it's going to start at -12. And it's going to keep on going up. I mean, you could draw those horizontal lines, but based on what we saw already, you really don't have to with quadratic functions. Okay, so we have that. I did draw the x-intercept, as you can see, this dashed line. Now here we have this example. So here we have a is -1, b is 7, c is 15. So from here, what do we get next? Well, we want to get the vertex. So we have minus b over 2 times a, as you can see. And then from here, we have -7 over 2 times -1. Again, we have b is 7, a is -1. So we get 7 over 2. I mean, you could leave it as a fraction. I wrote it as a decimal just to make it easier. Also because it's a nice decimal, it's terminating. We have this. Now we plug it in to get y, and that's what I'm doing here. As you can see. All right. So what's our vertex then? 3.5, 27.25. As you can see. And the axis of symmetry, again, that's x equals 3.5. And we do know the range. And how do we get the range? Well, again, what we can do is this. We have a is -1, so we know the graph has to open downward, right? We know the graph has to open downward because a is negative. The vertex is at the top. So because of that, the range, it's going to be everything below the vertex. Or actually, a better way of saying this is, it's everything below 27.25. That's how we get this. Not only that, what quadrant is the vertex in? Well, that's in the first quadrant, right? Up here somewhere. And since it's opening downward, what's going to happen is the graph eventually will have to cross the, x-axis. I mean, it will have to cross the x-axis. Those are supposed to be arrows. Let me see if I can draft that a little bit better. It's not easy to draw like this, so bear with me. But this is telling us that, okay, so eventually it will have to cross the x-axis. So there will be x-intercepts. And we can figure out what they are using the quadratic formula. I mean, they're not super, how do I say, they're not super nice numbers, but they're okay. We have the y-intercept also. You replace x by 0, and you get 15, as you can see. And so we use the wonderful quadratic formula, like so. And so from here, we have minus 7 plus or minus 7 squared minus 4 times a times 15 over 2 times negative 1. So we have this. We have a plus here, don't forget, because we have minus a negative. Now, 109 is not a perfect square, which is where these decimals come from. Not sure why that's a minus there. I got to fix that. But we do have decimals, though. That's good, because now we get the graph. As you can see, we have the x-intercepts. We have a y-intercept, vertex. And we're right that the graph does point downward, as you can see. So that's what we get. Any questions on this? I was going to do the next example as well. Okay, so for this one,